Okay, let's talk about real versus ideal gases. Let's get started. All right, here are the objectives, the standards. Pause it, peruse it if you want. All right, so first, in terms of volume, an ideal gas has no volume. A real gas actually in reality does have volume. So in reality, we're not going to be able to get to no volume. Okay, so the gases that occupy the least volume would be the most ideal. But if it were truly ideal, it would have no volume at all. In terms of mass, an ideal gas has no mass, but a real gas has mass. So in terms of being more ideal, it would have less mass. Okay, so it's not realistic to have no mass. We can get very small. So again, ideal gas conditions, the gases with the least mass will behave most like an ideal gas. Just like the gases that occupy the least volume, those particles, they will have be the most ideal. All right, what about intermolecular forces? Well, an ideal gas has zero attraction, no intermolecular forces. There's zero attraction between the particles. But a real gas actually does have intermolecular forces. There are attractions between those particles. What about the collisions between molecules? In an ideal gas, those collisions are always elastic. That means there's no loss of energy during the collision. Okay. Also, the amount of energy in the system remains constant, even in inelastic conditions. But in real gases, we do have non-elastic collisions. So if you look, if a gas molecule repeatedly hits the side of a container, it will hit with less and less energy or force as it moves on. Okay. All collisions are not elastic, but in an ideal gas, they would be, meaning no loss of energy. Okay, so real gases will behave most like ideal gases at a low pressure because they're occupying less space. So there's less chance for collisions between them, less chances for intermolecular forces to play a role. Also, ideal gas conditions for real gases is at high temperature because they are moving rapidly, okay? So real gases behave most like ideal gases at high temperature, okay? The particles are gonna be moving too quickly for their intermolecular forces to play a role. Okay, so ideal gas conditions, again, real gases will behave most like ideal gases at high temperature and low pressure. All right, so ideal gases follow all the gas laws at all temperatures and all pressures. But in reality, real gases follow the gas laws best at high temperature and low pressure. And then remember, small molecules are going to fit ideal gas behavior better than large molecules. And then nonpolar molecules are going to fit ideal gas laws better. Why? Because polar molecules have areas of positivity and negativity, partially positive, partially negative. That's going to increase the attractive forces. So nonpolar molecules have the least forces of attraction between them, so they would be the most ideal. And there you have it. That's real gases versus ideal gases. I hope you learned something new today.